Hi guys, we're getting into kinetic friction. Okay, and kinetic friction is basically telling you the amount of friction there is between two surfaces when two objects are sliding over each other. So if I slide the calculator over the board, it's got some friction because if I give it a push, it would move forever and ever and ever unless something stops it. So we know that something stops it. Okay. So, and we talk about kinetic friction, we talk about something called the coefficient of friction. Okay, and that's represented by this symbol right here. We call it mu. Okay, this is called the coefficient of friction. Okay, and generally, if we look at it as this, 0 is no friction. That's a hypothetical situation. 1 is the most friction. Okay, so this I can put a sub k on there to show me that it's a kinetic friction. So this is just a number. Okay, it's no units are attached to it. We call it mu. So let's take a peek at one of these questions. I'm going to look at number 40. Okay, number 40 says the coefficient of kinetic friction between an object and the surface is 0.4. So the mu sub k is 0.4. The mass of the object is 3.2 kilograms. Okay, and it asks me what is the frictional force on the object. So when I first started the lesson, the dynamics lesson, I gave you guys kind of a pun on formulas. And I said, and some of you may agree, some of you may not agree, but I said physics is fun. Okay, and this is the formula I gave you. Physics is F equals mu n, fun. So when we look at this, finding the force of friction, all we're doing is we're taking the coefficient of friction between the surfaces and multiplying it by the normal force. So a question like 40, you would have to draw a free body diagram because you want to find out what that normal force is. Now, the object's sliding. Okay, so it's got, we'll call this force applied, weight, normal force, force of friction. Okay, so one interesting thing about the normal force is that it is equivalent in magnitude to the weight, just the opposite sign. Now, the reason being is because if we had an unbalanced force pulling in either direction, down or up, then that object would be shown to be accelerating down or up. And we know that's not the case. So the n has to be equivalent to the weight. And we know weight is a negative number. The normal force generally will be positive, except in a situation like a roller coaster. So we've got this formula. Force of friction is mu n. So mu we got is 0.4. N, well, we don't have that yet. Okay, let's take and find out what n actually is. The weight is equivalent to the mass times the gravity. Mass is 3.2. Gravity is negative 9.8. So if we multiply those things together, the weight is negative 31.4 newtons. That means the normal force has to be 31.4 newtons as well. Okay, so we found what the normal force is, and we know that the force of friction is coefficient of friction times the normal force, 0.4, times 31.4 newtons. So let's figure that out. Okay, so the force of friction is equivalent to 12.56 newtons. We don't know exactly the way that this is getting pulled, but according to my diagram, I would call it a negative number because it's going against the applied force. So that is how to find the force of friction. Hopefully that helps, and I will we'll do another video with finding that coefficient of friction. Okay, these are numbers. It looks like 38 to about 46. So 38 to 46. Going to get number 46 solved as well on the next video.